notebooks, as you can see on my browser. We will browse from one to the other. We will execute. It's not really easy to type them, so I'm taking help from my old notebooks, which I will anyway share all the notebooks, even if I don't find time to discuss them. The only thing which I feel missing in this course, because I wanted to keep it general enough, is a full-fledged data analysis with pandas. Okay, so I'll only show simple examples. But for example, earlier I showed some COVID data analysis, how you can correlate data from different geographical regions and social causes, etc., which by itself will take a whole lecture. So I cannot do that. I will only show simple one. So let us start with the famous Titanic data. So if I go, let me go to go to a shell first. Okay. So first of all, let us look at the Titanic data, which is in this case is CSV or comma separated file. So I have this data. Okay, I have this data, and I want to analyze this data. So it could be very easily some of our like high energy physics analysis also data, which instead of in root file you could have in CSV file. If it is in CSV file, you can also use the Pandas data frame to do the analysis to quite a large extent, which I cannot show due to lack of time. And then you can plot them. You can select your event and plot them. Okay, so we will take a more general approach and look at the Titanic. So CSV file, as you all know, the first line is the header line. Okay, so you have certain like the passenger ID, whether in the Titanic accident that passenger survived, what was the class, the name, gender, age, and there are few others. So ticket, fare, the cabin. We will not actually use all of them, but of course, what we are going to use is the gender. For example, if we want to check how many males and females were there in the Titanic, then we can find that out. We can find out what was the distribution of age of individual passengers as a histogram. We can do that. We can also look at the average age of all passengers. We can look at survived. Okay, we can also look. We can also do some correlation about who survived and who didn't survive, etc., etc. So let us open that. Let us open that. So this is the one. Now Pandas is a module once again in Python. So you import Pandas, and by convention you import Pandas as PD. Everybody does that. So you import Pandas as PD. Okay. Now you have the plotting package. So the module, submodule, etc. You sorry. Your module package is Matplotlib, and within that package you have a module called pyplot. Okay, so you import that as PLT. So these are the two things which we use here. Okay, and then Matplotlib is a big monster. So there are many different configurations. There are many different styles. Although, as I said, there are much more improved plotting packages also, like Plotly and others. There are many of them which we don't go into. If you are curious and you think that you want even higher quality than Matplotlib plots in your analysis, you have to explore those. But then you have to also learn the particular, I mean, how those packages will be used, and we stick to the Matplotlib. So you can use a style, particular style. You will see from the documentation there are many styles, and here I am choosing something called Seaborn White Grid. Okay, so there are many of them. You can play with them. Okay, so once you have that, so let me take this one out and put it in a separate one. Okay. So first, without further ado, I execute it. So I have I have pandas already installed on my system. So you should also have pandas on your system. If you, I mean, if you use PEEP or other Anaconda like thing, actually you will get the recent pandas and other libraries. But for this these purposes, for the lectures, I am using the pandas from the system, which is a few versions behind the bleeding edge version. So if if some of the examples when I execute fail, that may also mean that it is not fully supported in the pandas version that I am using. But I hope these things will work. So once you have pandas loaded as PD, once you have the Matplotlib PyPlot module loaded as PLT, and you have set the style, now you can simply read the CSV file, okay, using the module. Okay, so there you have something called a read CAV. So the dot CSV. So PD is your module name, and you have a function called read underscore CSV. You simply pass the CSV. Okay, now sometimes, although the name is CSV, people may not use comma as the separator. People may use something else as the separator, like a colon or a semicolon, etc., etc. That also is accepted as a CSV file. But in order to read it, you have to specify the second. I think it is something like this. Another argument where you will put like semicolon. Okay, so even if you have a file where you have the header file and all the data record, which we have already seen this one, and instead of comma it is separated by semicolon. It is still considered as CSV file, but in order to read it in pandas, you have to also specify the separator. For the time being, I don't specify the separator, okay, because the default I have the default. So I read it, okay, and you see that is absolutely fast, because the amount of data is not very much. It's a small file. If you look at it, it's only like 60 kilobyte. Okay, so it's absolutely nothing. So you read the whole thing. Now you want to do analysis, but before you do analysis, you can simply say describe my data frame. So pandas, when you do this, it will return the data frame. Okay, so what you can do is you can say print type of df. That is the usual thing that you do, and you see that the type of df is actually a data frame, and then this data frame sits very deep in the package hierarchy, pandas core frame data frame. Okay, but it's a data frame. Then you can say any very simple thing, not simple, df dot describe. Okay, so there are methods describe, and it will describe. And now you see that because when you read the CSV file, I did not mention, but the pandas is a tool. Pandas is I mean the data frame, not pandas. Pandas also has a series object which actually works with a column. But here, and if somebody gives you n number of columns, you can also add them up to make a table. So the data frame actually is a tool to analyze tabular data, and you can see that it's a table now. So the data frame has converted the CSV file into a table. And what you see are some information. Many of them are not very useful at all, but at least you see the passenger ID, survived, etc., all the headers, and there are some numbers. If you have more mathematical data, then these rows will make more sense. Here they don't make much of the sense. For example, this one, for the age column it makes sense, for the fair column it makes sense, because you can see the minimum value and the maximum value. So you can see that the minimum value for the fair was 0 and the maximum value was like 512 in some unit. Okay, then also you have the mean value, mean fair in that unit, and so on. And the first row is always the same because there are 891, not always, but here maybe some, also this one says that some information is missing, because in principle because this is count, all the columns should have the same count, but it is not there because some information is missing. Otherwise there are a maximum of 891 entries. So there were 891 passengers in Titanic as far as this file is concerned. And then of course the passenger ID mean doesn't mean anything, so this column is useless. Otherwise survived also I think is not really, because survived is whether it survived or not, so it is 0 or 1. Okay, then maybe the mean value is correct, mean value makes sense, but not other values, and so on. Okay, so if you only want to look at the columns, nothing else, you can just, you have this member called columns. You can execute that, and it gives you all the columns, and it will also tell you that the d type of the column is actually an object, because it in principle it is a string, but because you did not specify that, it is taken as a generic one to be an object. It could be something other than string also. Okay, so you want to print the whole table? Yes, you can do that. Instead of this, I could also print the DF itself. Okay, I could also print the DF itself. Then what it will do is it will actually print the whole, not whole, the first few lines, which is the head part, and the last few lines, which is the tail part. So you can see that it is printing actually first 5 lines and the last 5 lines from the file, and there are all other lines are in between. Okay, this printing is slightly odd because it is not formatted correctly, but it is printing everything. Okay, so you can do that. Now you can, now comes the analysis part. For example, you want to, as I said, you want to plot the distribution of fare per passenger. So you have the, not per passenger, so along the x-axis you will have the fare, and along the y-axis you will have the number of passengers who use that fare. So and in order to do that, from the Matplotlib plotting package, you have something called hist. Okay, you can see that there is something called hist, and all you do is you simply pass the corresponding column. So these, you have the data frame. Data frame is my variable, which is df, and now you can almost use it like a dictionary. You just pass the key as the column, and it will return the whole column, all the values of the column as a series. I told you that Pandas works with 2 things. One is a series, which is like a column, and the data frame. Okay, so if you query a column in the data frame, then it will give you the whole column as an array. So that's what I'm doing now. So let me execute this one, and this 30 is the number of bins that I plan to use for this distribution. So I can do that. I enter, and you see that this is the distribution of the fare. So most of the people traveled with very cheap tickets. Okay, something like that. Similarly, we can also look at, okay, this one, if you want to put like 50, you will see that the binning is becoming thinner. Okay. Similarly, if you want to look at the distribution of the age of the passengers, you can do that, and you see that from 0, that means almost from newborn to people who are like 80-year-old, very old people, they traveled with a mean value of something. So you can also see the mean value. How do you see the mean value? You can just call mean or median. Okay, for example, this one is where you have added Python and data frame together. You have df, and you pass the name of the column, which is age. That will return you a series. Okay, in this case, a vector containing the value of all the column, which is the series, and you call, because that's a numpy array. Now it is clear to you. Numpy array, and numpy array will have something called a mean. You can call mean. So this will give you the mean, and you print mean in a particular order. So you can, if you want, you can check that. So the mean value is 29.7, and you can see that it is indeed the place where you have the mean value. Okay. So this is something also, if you want to look at the median of the age and fair, you can do that. And here once again you can see that instead of just passing one, you can also pass a list. Instead of passing only one key, or let's say key, call it key, column name, you can pass also a list. In that case, both of them will be extracted as two separate series, and the values will be computed. So you can see that for data with like 1,000 entries, it's absolutely fast, and Pandas is fabulous. It's really excellent. It can give you all the information that you want. Plus, it has integrated Matplotlib support, so you can do any analysis that you want to do. So if it is not like your high energy physics analysis, but some other analysis, then you are always encouraged to use Pandas. Okay. So more to that. Okay, this is fine. Now we will see. Now also survived. We know that survived will be either 0 or 1. So there is not much that you can do. So there will be, now at least you can say 0 means 500 something did not survive, and the 1 means they survived. So more people died during the accident than survived. Okay, something like that. Then you can look at the gender. You can look at the gender. I mean, you also have to learn the documentation. For example, this one, this one. So df gender. So gender is a column where it will be either male or female. Okay, in that case, male or female. And you say there is a function called, there is a method called value counts. So what it will do is that it will take the gender, and it will find the unique, it will find the unique key in the value, either male or female, and it will count the occurrences of both male and female and print it there. So it will say male something and female something. So that way, if you know the documentation, you don't have to do it yourselves. I mean, and this is one of the interesting examples of declarative programming. I told you that otherwise what you have to do is that you have, and here the limitation, one of the limitations is that once you start using a data frame, it is not very easy to get it. You can do that, but it will be very difficult to get the data out of the data frame into the standard numpy array and so on. Okay, because you once you start using the data frame, you will get used to it, and you will love the features that are available, and you will not do anything manually. That means you are actually doing a declarative kind of a programming. So anyway, let us execute this, and you see that it says male, female, 577 male, and 314 female. Okay, the column name was gender, and the data type was int64. Now you can also see more elaborate information that I am now getting both gender and age at the same time, because I am passing this this list. Okay, I am passing this list, so it will extract both the columns together. Okay, but then you group by, as if you are looking at a database. You group by the gender. Okay, and you get the mean. So let's see what happens. And you see that you have grouped by the gender. That is why your row will be female and male. And because you are looking at the age, so there are two columns, and you are grouping by gender, that means the mean value will be for age. Okay, and you see that the average age of the female were 27.9 years, while for the male was about 30.7 years. So this is a very high level information. Okay, and if you really want to do it by hand, if I give you two numpy arrays which are correlated, and if you really want to do it by hand, you will have to imperatively you have to write a large number, quite a few lines of code. Okay, here you don't do it because you have to learn the facilities of pandas, and you can see that I can do it without, I mean, and it is also very optimized. It will be very fast. If I do it by myself, like loops, etc., and it's the longer the column becomes, the slower my computation will become. But here in this case, it will be all done in C. Okay, so the performance is not an issue unless your data size is billions of entries. Okay. Similarly, you can also do gender, age. Okay, again, you are grouping by gender, and you are asking for max. Okay, you are asking for max. So then you will see that the maximum age in the female passenger was 63, while that for the male passenger was 80. So this is also another very important, I mean, not very important, I mean, as far as this information is concerned, but a very important operation, which you do it in one line. But if you had to do it by yourself, you have to develop by yourself the software, it would have taken a huge lot of lines. Okay. So similarly, you can also check more things now. You have, you see that you have, instead of taking a data frame, so this will be a data frame, DF of this will be a data frame, either a data frame or two series. Okay, and here what you are doing is you take the whole data frame, you group by, now you are not grouping by one, you are now grouping by two things. One is the gender and one is the passenger class. Okay, and once you group by that, you look at the fare and find the mean of the fare. So it is even more complicated, not complicated, complex operation than the other two. Okay, so you can do that, and you can see that you have the gender, which is female, and there are passenger classes. For female you have 1 2 3, for male you have 1 2 3, and for each such class, like there are 6 classes, because for female there are 3 classes, for male there are 3 classes, altogether there are 6 classes, and you have the mean value of the fare for each class. So you can see that again you have performed this very complex operation in a single line. So what I'm saying is that they look daunting, they do, and you have to get used to it. That's for sure. You have to get used to it, and once you get used to it, you will find that it can you can achieve a lot of stuff without with very little keystroke or okay. So now also you can have df group by, once again you group by gender, because you have only one key now. It's also equivalent to in, I mean, you see that if you have two, then you have to pass a list. If you have only one, you can just pass the string itself. It will consider a list of size 1. Then you look at survived, okay, and you do value count. So here what you are saying is that how many out of all the female, how many survived, out of all the male, how many survived. So let's see whether this is what it gives me. Yes, so that is what is giving me. This is gender. So for the gender, there will be survived either 1 or 0. For male, there will be 0. Okay, anyhow, it could be 1 or 0 also. So out of the female, 233 survived and 81 did not. And similarly, out of male, only 109 survived and the others did not survive. So all this information you can get. So this is your pandas for you. Now you can also, like I already did, you can also plot all this stuff. Okay, so how do you do it? Now let us plot something called age distribution of Titanic passengers. Okay, people who survived and people who did not. Okay, so you have So there I have to explain a little bit. What I am doing is that I have now two plots. Okay, one plot is where I will look at the survived. The other plot is where I will look at the ones who perished. So let me first execute it and see whether it works. Okay, so it works. So there are survived is with one shade, the perished is with other shade, and we know that the number of perished is higher than survived. And we see the usual trend. Historically, we all know that the people who died are of this age group. Okay, and they wanted the either the older people to survive, so it goes down. Okay, they can't the perished part. Okay, while the survived part also has something, but we don't really care about the survived part. We care more about the distribution of age for the perished people who did not survive. Okay, so this one I think you can do more. I mean, given the number of columns, you can do more. Now if you are curious what this is, then I will say that this, if you have a data frame df, okay, then what you do is you pass the column called survived. So this will give you the series. This will give you the series, which is a numpy array. Now that's another numpy array. I could just save it and show you. Okay, but that is not really important here. Then you say that equals to 1. That means they survived. So from that array, you are selecting only those elements where the value is 1. So if you have 891 such 891 such number, the column size, then you say who survived. So this will be some number. This will be some number, and for those people, you get. So because every time you operate on a data frame, you get a new data frame, this or a series. You have to understand that. So this one actually will give you, this one will actually give you, so sorry, this one will give you a series, and this equals to 1 will give you a column, and from that column you have something called a location. Now things become a little bit more complicated. So the data frame has a method called location, which will give you the position of, in the original data frame, position of some indices. So this one will give, you this one will give you a this one. Okay, let me just check. uh, this will give you a column where all the where the passengers survived, and df of log of that column will give you the location or indices of all those people who survived. Okay, and then you are asking for the age, because the whole thing is also a data frame, and but the data frame has now changed in size, and you are asking for the age. So it's it's super complex. Once again, you have to get used to it. I mean, if I am not in touch for some time, I also forget. So this way you are getting a, because you are now asking, the last thing is the age. You will, at the end of the day, you will get again another array, another column. And because it's a column, you can for the numpy array also, you have a function, you have a method called plot. You can just plot it. And because there are two ways of plotting. In one case, you plot using the module called pyplot, and in the other case, pyplot is already a part of the data frame. So you can also directly call the plot method of the data frame series. Okay, so this is what I have done. And there, because I am plotting, I am also telling that the type of the plot will be histogram, and I want to fill it. I want to give some transparency, and the label will be survived. So you see that it's a high level way. So if you had to do it yourself, you have to write a few lines after you save. So what you could do is you could save the whole thing in an array, and then you could say plt, like I did here, like you could say plt.hist, and then pass that data, and also you have to pass some more parameters in order to do that. So instead of doing that, here what I'm showing is an embedded plotting package inside the data frame. Okay, so this is the same, and then you put the X level, which is here, which is the Y level, which is here, and also you have a title somewhere here. Okay, and then you say that you see that at the end of the day, you are again using the plotting package to show the whole thing. So this plot doesn't really plot it. It actually prepares the histogram. This one prepares the histogram, and then finally, when you say PLT show, the whole thing will be shown. So complex, but anyway, I hope it is interesting too also. And then there is something again, age distribution. I think this is the one which I told you that instead of showing this, I can also save the data, okay, and use this standard histogram function from the plotting package. So these two should be equivalent. So if I do this, let us see. Okay, I have done it in a slightly different way, just to show you that there are lines and line type, etc., etc. So these two, as far as the distribution is concerned, they are the same. If you like this way, you will do this way. If you like this way, you will do this way. So what I am referring to here is that if I give you, I mean, not all of you are high energy going to be, I mean, particle physicist or astroparticle physicist, but if you become and you want to do your analysis where your data is not of huge volume, you can use also data frame, and you can see that after the analysis, anyway, the one of the final outputs of the analysis is histogramming, so which you can achieve here also. Okay, so this way I I hope I have given you the first taste of how pandas work. So pandas, because I am not introducing pandas at all. So, and there is not much to introduce either. You have to just go through the reference manual, find the facility that you are looking for, the functionality you are looking for, and you will use that functionality. Okay, so that's how I learned. I think you will also learn the same way. So essentially, Pandas is a big one with a lot of functionalities, and we are really concerned about the data frame here. And so there are two concepts, where one is a series and another is a data frame. One can think about a series as a column, and if we add several columns side by side, it becomes a data frame. So if somebody gives me a data frame, I can also split the data frame into many series. Okay, so there are many other ways of manipulating it. So this one, I think, now is done. So I'll go to something else. Uh, so let us see how India and China population, okay, actually compare over the years. Okay, another example, simple one. But so you have, instead of the Titanic, I can now look at the population. So again a CSV file. Okay, and in the CSV file, you see that there are only 4 values. One is the country name, one is country code, the year, and the population value. So from 1960 up to some point, you have the population value. I am only, and this one, sorry. So if I do, so you see that I have like 15,000 lines in this file. Okay, 15,000 lines. So the file size is about 500 kilobyte. Okay, absolutely nothing compared to what we expect. But if you have derived data for your analysis, I think this is not a very small file. Okay, but a few megabytes will be a good number. But for raw data, it could be few gigabytes, many gigabyte, and then the CSV are not the good option. Okay, you need binary representation. So when you have small files, then you can have text format, which is the CSV. Okay, so, but here it has to be CSV because you should also be able to check by eye. Okay, the value. So let us say I check India. Okay, you see that from Indian population in 1960 was like 45 crore. Okay, and from there today when it was last updated was 2018. It was 1.35 billion. Okay, so that's fine. So what I'm going to do is I'll read right now. I'll read the whole CSV file into memory, and then from the memory I will extract the columns for China and India. I will assume here, because there are things which I assume that both China and India have entry for all the years now, starting from 1960 to 2018. So there are no missing entries. So that when you compare the two, if we wanted to compare the two as two series, actually there is no mismatch in the number of elements. Okay, and in Pandas, which I will not show, if Pandas finds when it reads the CSV file that some value is missing, that means you have the comma, but then immediately after that you have another comma, and in between the value is missing, then you can, it will, once Pandas reads it, and you can ask where I have missing, data missing. Okay, data missing. So if Pandas will tell you here and here you have data missing, so you can take a decision. You can either say that, okay, if there are missing data, remove that row. I don't want to analyze that row. Then it will remove that row and make your correct your data frame content. Okay, or you can say, okay, if it makes sense, if that data is missing, either I put some default value, so it will put a default value, or you say that you take an average of the first 10 the 10 lines before that and 10 lines after that, and put that value in that element. It will also do that. So there are many ways in which actually you can normalize your data frame once you have read the CSV file, which I am not going to show because that is a little bit more technical, but you can do that. Okay, it's not that you will fail because some field is missing. So if the field is missing, either you remove it, or remove the whole line, whole record. Okay, or you correct the field. Okay, so with that, let us once again, because this is a different notebook, I again read the two. Okay, I read the two, then I now once I have the two modules loaded, I can now read the population.csv, and you see that also this is absolutely fast. Okay, but this could be because I have already read it earlier also. Now df, okay, once you have that, it is always a good idea to do d of df. Okay, and you will see all the functionalities that it has. The ones with the underscore, either 2 or 1 underscore, we will probably keep aside, and you can see there are lot. And then the ones which are public, okay, you can use. So one of them could be head. One of them could be head. 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 So head is like the Linux or Unix head. If you want to look at the first 10 lines of a file, you say head and the name of the file. If you want to look at the first 20 lines of the file, you say head minus 20, name of the file. Similarly, also here you can do the same thing. Let me go down. So where is that? So head. I want to look at like 20 records, the first 20 records. So I press it, and you can see that I am looking at the first 20 records starting from 0, which the index is added by itself. Oh, okay. If you want to look at the data frame and convert the whole thing into a string, you can do that. You can simply say df dot to string. I'm not hitting that because it will okay, I can do that if you want. And you see that it shows the same thing, but making everything into, so it is as if a printable version. Fine. Okay, now comes that I want to convert, I want to extract from the data frame, the whole data frame which I have just read in, another smaller data frame which belongs to China, and similarly another data frame which belongs to India. So how do you do that? Again, it is rather easy. So you say if df and within quote country name, you saw the header, is equals to China. So only those lines, only those records where the column name country name has a value of China, they will be extracted from the whole data frame and put into another data frame called DF China. Similarly, you do DF India. So now you have you can forget about the others. You just play with DF India and DF China, and you assume, you can also check, you assume that they have the same number of elements. I mean, here probably I'm not really doing anything very fancy. So even if they are not exactly the same, it doesn't really matter. So once you have the two data frames, you can now plot the value, which is the population, as a function of the year. So depending on how many entries there are, you can just plot it. So you do plt, which you imported, dot plot, then you pass the column, which will give you a numpy array, and then you pass. So this is the year, and then this is the value. This will be the y-axis. Okay, another numpy array, and you label India, and similarly you label China. So this one I have to execute in order to get DF China. This one I have to execute in order to get DF India, and you see that this DF underscore India or China, they are also data frame, and I just execute this one, and you see that which one is India? India is blue, and China is the other color, orange color. And you see that the gradient of India is steeper than China. And in 2018, India had not yet surpassed the population of China. But now if we add also the population up to 2023, India will go higher than China. So this, because this is an official CSV file, I think this is the correct one. Okay, you can also, instead of having such a this is a plot. Okay, this is not a histogram. Histogram doesn't mean doesn't have any meaning here. So it's just a plot, and you show the distribution as a function of x. What you can do also, like what people do, is also you can have a bar chart. Okay, instead of a plot, you can also have a bar chart like this. Okay, and here I am only probably doing it for India. So this is a bar chart. So every year, in a number of entries, you just put a bar, and we can see that it is, the population is increasing monotonically every year, and from that you can also calculate the gradient, etc., etc., how the population increases. But I now want to, like here, I want to do a little bit more. Of course, I will not show you how it is done, but I will show the result, because there are lines of code that I want to show both as a bar chart, both China and India on the same plot. Okay, and this is not absolutely trivial, and it is not like this. Okay, so what you have to do is you have to do few things. Okay, you have to do not much, but at least you have to make sure that the why you need to do some work, because otherwise what will happen is that in the x-axis you have year, and the y-axis you have the bar. If you don't do something, then the two bars will be on top of each other. Either you will see China or you will see India, but by putting some alpha, that is transparency, in principle you can see both of them. But what you can also do, that you can take the x-axis, you expand the x-axis a little bit, so that the width of each ear is long enough, and then you put the bar of India and displace a little bit, and then put the bar of China, and that is what is done here. Okay, we'll show the see the result. Okay, so this is what is done. So for that, what you do is you have to play a little bit with the plotting package. Okay, and so if I do this, you see that. Okay, so you see that the red one is India now, so India, and China is slightly displaced, so that you don't have to really put one on top of the other and put some transparency. You could do that. Okay, but here you can actually use any color that you want, and you see that 2018 they are pretty close. Okay, and then I don't think it makes much sense but I can also look at the scatter plot. I don't know what the scatter plot means, probably not much, because this is the value of China and India. No, this is not really very useful. Okay. So that's all. So this is also another way of doing some analysis, and I hope you have got the flavor. So then I will show you another interesting one that, okay, first of all, I must say that it is not only the CSV file with which Pandas work. Although my version of Pandas may not support it fully, the Pandas also works with the JSON file. Okay, I should have one example. Let me see whether I can find that out. It is not here. JSON. Let's say this one. JSON. Okay, so last time I checked, it actually worked. Let us say I have this data file. Okay, which one? V1. Let's just say I have the record of Sachin Tendulkar about his test matches or ODI matches, whatever. You can have either test match or ODI match, and you know the syntax of the JSON file. JSON file has this following syntax, that it is exactly the Python dictionary format. This is a Python dictionary format, and these are within the list. Okay, so a list of like a list of dictionaries. So you have you have the notation of a list, and within that list you have n number of entries. Each of them is a dictionary entry, and you can let us see whether it can read it. So once again, I have Pandas, I have NumPy and Matplotlib. These are the standard stuff you put everywhere. You can check. You can check whether what is the version of your Pandas, and you see that your Pandas is 1.35. I think if you have a bleeding edge Pandas, it will be even higher. Okay, but that's okay. Now let us see whether it can read the JSON file. Okay, we saw the JSON file, and yes, it managed to read the JSON file. Okay, so once it manages to read the JSON file, the rest of the thing will be the same, in the sense that then it becomes a tabular data like this, and you can do whatever you want. Okay, and what is this V version 2? Let us also check that. And you see that version 2, because I had two versions, okay, due to my Pandas versioning problem, I had to play with that. Now you see that I have even a simpler JSON file. This JSON file is more like a CSV file, because here what I'm saying is each line is a dictionary, but it's not a list of dictionaries separated. Each element is separated by comma, etc. etc. Each line is complete by itself, and there is nothing else. So this is also to Pandas. This should be a valid JSON file. So let us see whether it can read it. So that's what you had to add this line called lines equals to true. That means earlier you did not say lines equal to true, because that was a more grammatically correct JSON format. Now it is less grammatically correct JSON format. So you tell Pandas that, okay, I am not giving you a very correct format, but you assume that each line by itself is a part of the JSON entry. So if you do that, and you see that it can read it, and again it will be the same. Okay, if you have a CSV file, as I told you, and you want to read it, then if the CSV file, this is just to tell you that there are CSV file.
Sir, can you please again show what is the difference between the two JSON files that you?
The first JSON file, yes, the first one is a JSON file where you have a list. If you really look at this, you see that it's a list, no, Python list starts with a square, the square bracket. Okay, and there are entries. This is one of the entries of the one element of the list, then separated by comma, second element, third element, etc., etc., goes up to the end, and your list also ends. So
Yes,
this
sir.
is one of the JSON entries. So which one? So while the second one is open, it doesn't have the list kind of notation. It is
Okay.
all lines are independent by itself. There is no comma, and that is why you tell Python, tell Pandas that I have each, so lines equals to true. That means each line is a separate it's a record by itself. Okay, it's not a list. So what I said earlier, now you can check if you want, is that if I have a CSV file which is actually not separated by comma, but it's just a table itself. So this one, it's a table. Okay, it's a table, and it is a little bit tricky. I'm not really going to do much, because you see that here you have the header, and then you have the values, but some of the values also have the star where he was unbeaten. Okay, so something may go wrong when you do the analysis unless you take care of that. But at least Pandas can read this file also in the data frame as a CSV. But there you have to specify that although I am calling it a CSV file, the separator is a number of space, any number of space. So that is what I have done here. So I'm saying that you now read CSV. I am giving the CSV file, and as a second argument, I'm saying separator is equals to slash s plus. That means slash s is an empty space, a single space, and if I put a plus, it's a regular expression. It tells you that any number of spaces, because the number of spaces may be a variable thing. Okay, so it will consider all any number of variable spaces as a single space, and split the records according to that. Okay, so this also I can put in another data frame, and it also works. So all of them are equivalent. So it's not only it's not only the CSV, very strict CSV. It can read JSON file. It can read also normal text file separated with empty space. And in principle, a well-behaved that means, I think it is already now developed. I don't remember exactly. It should also be able to read XML file, and even to TOML file, and so on. So any data format which are popularly used in Python, okay, YML, TOML, etc. They should all, maybe they are could be difficult because they are not really tabular data. Okay, while XML, okay, JSON, and CSV are very directly tabular data. So it should not be very difficult for Pandas to implement reading functions which will read the data and put them into the tabular form. Okay. So what you can
Sir, is there any difference in reading the CSV files with like dot slash and without dot slash? Like in the first example, you just you didn't put the dot slash then file name, and in the
Oh, no,
Tendulkar.
it's not. So okay, no, I think it's the same. I just probably it failed. I just meant that you read it from this directory. So because the file was probably somewhere else, and I just want. So I can remove that. I can remove that. It should work. Okay, it's not a
Okay,
problem.
okay, sir.
So, so the another important point here is that you can also take, for example, df2. Df2 is where you are reading from the CSV file. Okay, you can also convert. Pandas not only reads it, it can also output it. So let us see this one. So df2 is from the CSV. Now I am converting into a JSON file, and this is important because this will tell you which is the kind of JSON format that Pandas is expecting from you, because this is the one which it is outputting. So this is what is interesting. So I enter. then I have a file called data.json, and I open that file, data.json. Okay, and you see that it has a slightly different syntax. Okay, everything is a dictionary. It is not a list. It's a dictionary. It starts with this parenthesis. That means it's a dictionary. So year, and then so it's a totally different format. So the one which Pandas outputs is a different one than what we actually use at input. We use two different formats as input. Both of them worked, but if we had to follow what Pandas does, then we have to follow this one. And also you can see that here it's not formatted in a human readable way, because it has to be compact. So when you write data, in principle, your JSON should also be very, very compact if the size is big enough. Okay, but sometimes readability counts, and your data file is not very big. Then you can do what we have just shown. Okay, so this you can check for yourself. So I think this is for what is that, JSON, and mostly JSON, how you can use. Now, at the last time when I was using this Pandas, it was not able to read XML. Okay, so what I could do is, let us see. So if somebody gives you an XML file, like for example histogramming purposes, this is a very small example. Then in Python has XML parsers. At least there are two different XML parsers. One is called a mini DOM, and another is the tree-based parsers. So if I give you an XML file, and if I want you to get me the histogram back from the XML file, you can do this. I'll share this example. So let us say I have an XML file, okay, where I have a histogram, because I don't want to use root. I just want to share my histograms as an XML file. I can do that in principle. Nowadays maybe you will share it as an YAML file, okay, one histogram with all the data. And when I read it back, I should have a tool which will read that YAML file and convert immediately into a histogram and plot it. So let us do that. So I have this histogram file. So it's an XML file. If you don't know about the XML format, you just assume it, that in the XML file I have different tags. One tag is a plot, tells me that this is one histogram. There could be many histograms put into a single histogram file, like a loot file with proper tags, etc. And we are here I am only talking about one histogram, so it's fine. So I know that a histogram has a name, it has a title, you will have the number of entries in the histogram, because it's only data. Then you will give me also the histogram binning, because you read the histogram and convert it into an XML file, and you give me the data. So data is bin content and bin error. So this is a very simple XML file. Okay, but this is data which I have given you. Now you want to read it back. And you want to plot it and see what result actually it looks like. So this is an aside, in the sense that you should also know that Python has powerful tools to parse XML files. I'm not really going into that detail, but it's called a tree-based parsing. You will just read the XML file. This is what I have done. I have read the XML file here, okay, and I say it parse. Okay, so once you have parsed, this tree object will now contain all the elements of the XML file, and you query that element, and it will give the value inside that element, and so on. So you can query, for example, here I am querying the name and title, and it's not really that easy, because there are methods with long names, and it will return me the the values corresponding to the name and the title. Similarly, and I will put them in a dictionary. I'll put everything in a dictionary, and you will see that I have put the name, title in a dictionary, the entries in a dictionary, the number of bins in a dictionary, and then I am also putting the mean and max value in the dictionary, and finally bin content and bin error, which are vector, I mean arrays or list values, I am also putting them in a dictionary. So then I can print it. If I print my dictionary, I will execute it now. We will see that it has already extracted the whole XML file. So this example is very simple, but you can think about XML file of more complex XML content, and you can still extract them with the tree method or another. It's the same, but there are some differences. And then once you have that, you can actually now plot it. To plot it, you will just take the bin content. In principle, here I have not shown it. You may also take the bin error, okay, so that you can put the bin error there. And then you have the mean value and the max value. You will define your number of bins distributed over the mean and max, okay, and then you plot them. Okay, so let's execute it. So this is I am importing thing, and this is where I am actually parsing the XML file, and you see that all the data are now parsed and properly put into the dictionary. So once you have the dictionary, I can get the data from the dictionary, which is hist of bin content, okay, and then I'll just plot it, and you see that I have. So this was a Gaussian thing. So I have managed to. So this has nothing to do with the pandas. Okay, this is just the Matplotlib. I told you that I'll show you a few examples of the Matplotlib, and this is one of the examples where you can you don't have to really be a part of the NumPy to get some data. You can also get data from external sources and convert it into into NumPy array, or even simple list here, because given the number of bins, it's not a big one. You can just use the Python list, which I have used here, and work your way. Okay, so this is one more example. I think I should, now that I am showing you, I'll quickly go through what Tendulkar. This one was the test matches and how I compared them. So once again, let me execute it. So I am now reading Tendulkar's test match record. Okay, and I'm looking at the head. It shows me 5 results. As I told you, something may go wrong because of the star, which I should have removed, which I have not. Then you describe the runs, because it makes sense. You can, if you describe the run, it can give you the mean value. It can over the years, it can give you the maximum value over the year, minimum value, and so on. So if you do that, you see there are mean values for year, because he probably played for 25 years, maybe. Yes. Yes, so he played for 25 years. So that's why the count is 25. The mean value is 636. His max value in some year, when he was in top form, 1562 runs in that calendar year, and also minimum will be very low, 58 runs, and so on. Okay, others may not be that useful. Okay, so the highest run, again, you can describe the highest run. You see, again, the count will be the same. And okay, this is not. Now let us plot it. Now let us plot something and see what happens. Okay. So starting from, and you see that I have two subplots in the same plot. So this is also for you to show that you can do it. So you have the matches, you have the innings. Doesn't mean much. And you have the runs. And this is a cumulative sum of the runs. Okay, this is also cumulative sum. And you see that I have used, instead of sum, I have used the cum sum. Okay, cumulative sum also you can get, because that's how runs are going up to the 15,000, which is the total run of such event. Similarly, you can have his average runs year by year. Okay, starting from this to this. This is a bar chart. You can also have his centuries. Okay, which year he made most of the centuries. You can check that. Okay, and you can also check the year by year, which year he scored most of the runs. So all these things you can do. And if you have a very nice plotting package, like maybe slightly more optimized than this one, you can also put legends, etc., to make it better. And now once again I will make bar plots, and in order to make bar plots, every time I have to write some Python code. Again, I don't want to really go through them. If you are curious, you can check them. So let us see what happens if I click on that. No, okay, so something is wrong, but otherwise I am showing you year by year the values, probably the average value, but this time in a horizontal bar, so that I can also put the numbers here. So for example, here I could not put the number. It doesn't really make the whole thing readable, but here it makes things readable, that I put the year here. I put this axis is the average value, and for each year I also after that I even put a value. Okay, so this is just to show you that with Matplotlib you can do all these things. Okay, so similarly you can, I think, click the 50s. Okay, 50s, and I don't know what it will give me. Okay, so this is also an interesting one. So every year, how many centuries and half centuries he actually scored. Okay, so whether they correlate each other and so on. And finally, I don't know. Let's see. And you see that in Pandas you can do also a very interesting one. You can actually, instead of having an index which is 0 1 2 etc., you can set your own index. What I have done here for the data frame, I have set the index to year. So instead of showing 0 1 2 etc., now the year has gone out of the column list. Okay, now year has become the index and it shows. So this is a nicer way of showing it, of course. Okay, when you look at the table, it's a nicer way of showing it. And I don't know what this will mean. This will be okay, this doesn't mean much. Okay, once again, this scatter plot doesn't mean much. Okay, so I think now I'll move to some of the pandas part. I think I have done more or less. As I said, I have one large example where we analyze the COVID data. Okay, but I don't want to show it here because it will take some. I'll now go to Matplotlib and see what we do, because just to show you that you actually can do a lot of stuff. So let us say I want to do histogramming. Okay, so I want to do histogramming. I load the module, then I create some random number. Okay, this random number you are creating from NumPy with with about 10,000 elements, and you are doing a histogram. But by now you know how to do it. You have data, which is a NumPy array, and you have 100 bins. So that's it. So you print it, and you have the normal distribution kind of a thing. Okay, why it's a normal distribution? Okay, because it's the normal distribution that you are asking. So it is normally distributed. Now this one, now that you have the data, you can now play with the style of the histogram. So what you can do here is that now you can change the number of bins compared to this, and you can also add some alpha, which is the color can be changed. You can add some transparency and so on. This you will learn when you will do it. So there are some alpha and bin from 100, now you have 30 and so on. But because you can do that, because you have the original data, which is not a histogram, which is already in the NumPy array. So you can actually rearrange the number of bins. Then you have now 3 normally distributed NumPy arrays of the same size, and you will see whether we can superimpose on top of the other. Okay, so on top of the other. So yes, what is that? Why? Okay. So this one, you can see that now you can superimpose, and with some transparency, you can see all of them very well. Okay. Now, how you do it, you have to understand. So you remember that when you are plotting, where when you are plotting a histogram with plt.hist, you are passing also a number of keyword based parameters. This one, like alpha value, density, number of bins, hist type, and so on. So what you can do, you remember that in a function you can pass arbitrary number of key value pairs with the if the argument name is argument, then star argument. So that's what you are doing. You are defining that argument as a dictionary, and you are passing it like that, instead of repeating the same thing here in 3 places and making it clumsy. You just, for the common part, because this is a common part, you just define a dictionary and pass the this as the argument. While in the case of level, you cannot do that, because you want to make the values change. So this is a common part. For the common part, you will not really repeat many times. You will just define a dictionary and pass it like this. Okay. Okay, I think then you can probably see more important two-dimensional kind of or plot with the color bar. Here you have both X and Y. You created both X and Y there. And also I think you have another color plot. So what I mean that if some people who already know, I mean, if you already know root, okay, you know that in order to achieve this in root is not trivial. But so that way, I think the quality of plots in Matplotlib is much better than root with a smaller number of keystrokes. Okay, although the analysis part is slightly better, I mean much better in root, but the presentation part, not presentation part is easier, okay, in Matplotlib. That's why even if people use root in their analysis, after they do it, because most people use Python pyroot for their analysis, and you will learn pyroot there, okay, or uproot, whatever they do, at the end of the day, they don't use root for the presentation layer. They use Matplotlib or other even much better plotting packages for the presentation. That's why the slowly the de facto plotting package is going away from root in also in the publication. Okay, so this one now I will show. I have still 15 minutes. Error. Okay, this is important. If you do analysis, how do you show the error? So unfortunately I could not show you all the functionalities of NumPy. So there is a very important one, important function, which is lean space. Lean space, if I have 0, 10 and 50 as 3 arguments, that means from 0 to 10 you divide the axis into 50 different bins and return the values. So x will be a NumPy array of 50 elements. Okay, here it will be I mean divided with uniform distance. Okay? Similarly, you can say that now I have a dy which is from 0 to 1 again in 50, and then you can define your y by adding something to x. Okay, so I mean just by you transform x into something so that you can get y. So you have x and you have y. X has got like 50 values from 0 to 10, and y will be depending on the x values, while we'll have some values. Now you plot it, x and y. Okay, essentially x will give you the axis range, and you get the y values, and you, instead of saying hist, now you use the error bar. Okay? In the error bar you put x and y, and in the y error you put dy, because that is what we have you have defined, and then you have other things like the color, like the width of the caption size, and so on. So let us execute it and see what happens. This one, and you see that you have a very nice, let's say, histogram with the error bar on top of it. If you okay, so this is also something again long enough, but you will if you read it, you learn what it does. So you have x, you have y1, you have y2, and you have error attached to both y1 and y2. So instead of one, you now have two of them, and you are probably superimposing two of them. Let's see, subplot error or something. So now you are you have then there are two, yes, so there are two plots now, okay, subplots. So you are putting both of them, and here what you are doing is you are putting all the error bars in the first plot, and because that looks clumsy, here you are only putting error bars, or let us say you have rebinned it in such a way. You have not rebinned it because then the error bar would go down. You are not plotting all the error bars. You are only plotting every sixth error bar. Okay? This is just to show you that you can do such things. Okay, it is. So what it tells you is that with Matplotlib, you have a lot of power. Once you have the histogram, you can also put the errors. Okay, and so on. So the histogramming is done, and this is a scatter plot. I think scatter plot is even better in Matplotlib compared to root. You can see that. Okay, it has very interesting scatter plots. I'll not really. This is just to impress you. That means I'll not go through the data. Now that you know some NumPy, it is easy for you to create data. Okay, so these are the lines which create your data. Okay, and this data is ad hoc data, and this is the part where you do your plotting. So this is your plotting. If you want, you can even you can even have even more fancy one with the color bar. Okay, so all of them are really very high quality, as you can see, and they are very simple to understand, because once you understand the NumPy part, I think the rest of the stuff will not be very difficult. This one is not so easy because you are doing a fit also. As you can see, you are doing a fit also. Then you have the data, you have the fitted line, and you also have the error as the shadow. Okay, and finally, here you can also have even more. Okay, that means if you remember that when you look for the discovery, etc., you also put the vertical bar to show that here is where I have some excess compared to the expectation, and so on. So you can also do that, and again you can see that you don't have to do a lot of stuff in order to achieve that. So that is very important. Okay, but on the other hand, with root it is easier because a root doesn't have a lot of functionalities, and you have to achieve a lot with the limited amount of functionalities. On the other hand, and there it is more object oriented. Okay, so you know how to achieve it, and it will be uniform. And while in this case of Matplotlib, it is the dictionary based thing. So everything, when you plot, you have to pass an enormous number of parameters to the function. Okay, which I don't like myself, but as I said, it's a way, and it's faster with because you are avoiding object orientation. Instead, you are passing the parameters directly to the underlying software. It could be C, it could be, I think Matplotlib doesn't have a lot of C, because you have very high level plotting requirement, not a lot of requirement for computing. And C anyway doesn't have a lot of prowess in terms of plotting packages. So Matplotlib actually uses the if you read it, the major part of the Matplotlib software is written in Python. Only very little bit is in C. And when I say Python, it will not only use, I mean, it will, of course, it has to use some graphics element Python library, which is C, or not, or C++ or something else. But the library itself is mostly based on Python. Okay, what is so legend? Last one probably. The legend is that we have seen some legends with the plots. Now we can also have a look at some more details. Okay, once again I do the same thing. Then here again you have X, which is a NumPy array from 0 to 10 divided into thousands different divisions. Then you have a plot, okay, where the size is defined in terms of width and height. Okay, then you plot both the x twice. Actually, you plot the x twice, and y will be, I mean, you will have two plots. X will be x, of course, and y will be either sin x or cos x. Okay, and here you are telling what kind of line it will use. It will be double dot or single dot and so on. Okay, and let us see what happens. And you see that your legend, when you say legend, sine and cos, you have two lines. One is bold and solid, and one is where you have two hyphens. You have the dashed line. Okay? So this is something very simple. Okay, and as I said, in root, if you have to achieve this, you have to write many more lines, because you have the histogram object. You say set line width, you say set line type, you say set line color, etc. 3 lines. Here in a single line, you have achieved that. Okay, it's a default. If you want to change the color, you will add another key. So there are advantages and disadvantages that it may not be fully uniform. You have to keep your reference manual always handy, so that you can check how I do the plot, etc. By the way, it's also interesting to note here is that you can have the plot. You can have the plot on the module itself, that is plt.plot. But you can also have a subplots kind of function which will return you the object, okay, the figure object and the axis object, and based on that also you can, and then you can use the object method to plot. So for example, you remember, if I do plt.plot, I am calling a function of the module, and if I use ax.plot, that means I have an ax object on which also supports a plotting mechanism, and I'm calling that. So this you have to always follow. So to me also it is sometimes misleading about which one I will use, because there are, if I do pandas, pandas has got a plot. If I do PLT, I mean the module, it has a plot also. From the figure I can get a plot, and so on. So these, once again, you have to get used to. There are more, and you can also change the legend. For example, instead of, now that you have added the legend, by default it went to the top right corner. In principle, you could also do, if you just plot the figure again, you see that you have put the upper left instead of upper right, you have put it in the upper left. Okay, you can also change it. You can also change this to the lower, but lower center. But here you are passing another argument, which is ncol equals to 2. So instead of in one column 2 row configuration, now you are in 1 row and 2 column configuration. So all these are very flexible. All these are very flexible, and you have you can do all of them. Similarly, what is this? This is again no, this probably doesn't work. Fancy box 2, frame alpha, shadow, border. No, this did not work for me. Okay, this one. Okay, so is there anything left that I want? I probably covered the population part. I have covered the this one. I have covered Titanic. I have covered XML. I have covered basic histogramming. I have covered. I had to hurry through them. I fully agree, but because I did not talk much today and just only executed today, means now executed all this code. I hope you have enjoyed it and you have followed it. Okay, so this one, then Matplotlib. So let me go to Matplotlib once more and see whether anything else is remaining. As I said, anyway, I will share all of them. If you multiple plots I have shown probably. So contour, if you if you want to know, don't ask me about the detail. If you want to really do your physics analysis with Matplotlib, you can do that. You can set your limit. You can get very nice quality plots, etc., etc. So for that, I'll just show you that you can do that. Okay, so this one, for example, you see that you have a contour plot. You can have contour plot. Once you have the contour plot, you can also have contour plot with very fancy coloring scheme. Okay, you can even have this. So you see that uh, root actually requires more effort to achieve this, and these are very much available in pipe. I mean, Matplotlib, and probably in other plotting packages also in Python. So that way it is a very powerful thing. You can this one also, this is complicated in Python compared to root. If you have a scatter plot like this, you can have the x projection and the y projection, and you remember that in root this is one of the most powerful feature, that if you have a scattered plot, you can just move your mouse and you can see the projection on one axis or the other. Okay, here it's not so easy. And on top of that, another downside of Matplotlib is that root histogram are live objects. You can actually take action on the histogram itself on the canvas. But here, all of them are like PNGs, like images. So you cannot really do that. So if you have to do something like an animation, you have to really use the animation thing. But that also doesn't give you the power that root has. So that way, there are advantages and disadvantages. That means the quality of the root histograms are not that good, but the power of the root histogram is that they are live objects, and you can make changes also dynamically. You don't even have to touch the code, and you know that once you have finalized your histogram, just sitting on the canvas, just editing the canvas, you can save them as a root macro so that you can use it later on also. So those facilities are not there in the Python plotting packages. Okay, so this one, contour, and the last one I think is called coherence. Once again, this is just to show you that you can even do fancier things. What are those fancier things? So, okay, now this is not very fancy. This is a time series. Okay, this is a time series also, which you can do. Okay, so if you want to check the heartbeat, if you want to check something like that, you can, with time, you can use Matplotlib as well. Okay, with the kind of resolution that we have. Okay, so I think I will stop here, and I will thank you all for attending this set of lectures. It's true that I needed more lectures, like 10 lectures, if I were to do it at my own pace, which will be satisfactory to me. But these are accelerated courses. You don't really have time to spend 10 lectures on this. And I think I'm happy that I have covered part of the Pandas and Matplotlib, and I am unhappy that I could not cover some of the features of the NumPy. But so that's what I will urge you, that I did in the morning also, to take all the because I will share all the notebooks. So to take all the notebooks, go through them, execute them, and try to understand how they work. Okay. Thank you very much. If you have questions, I can try to answer.
Hello, sir. Can you hear me?
Yes, I can.
Sir, so as we know that, I mean, in our community, high energy physics, from the beginning, I mean, being a student, I have heard that the root framework was developed because we have a huge amount of data, and I mean, the raw data comes in, and then we process it and compress it and save it in a root file. And one of the motivation to build this root was to save this large amount of data into smaller files so that it can be easily be portable and people can do the analysis and all. So I would like to know your comment on this. What we learned today, this matplot and these pandas. So is it the same thing? It can be done with because as you said this in the root what we have. Let's say we process some data and we can get the live object and we can save it in a root file. And whenever we want to, let's say, rebin or do some operations can be done. But here no such thing can be done if you process your data and make some final plots or something like that.
Okay, yes, I agree to some extent that root was, root and pandas or matplotlib are two different things. One is the industry standard, no,
Mhm.
because millions of developers actually write code in pandas, in matplotlib, and so on. That is why it has progressed so fast. While root, as you rightly said, root was built in order to make sure that the petabytes of data can be stored somewhere. And not only, this was one way, so that you have a data structure which can hold hold petabytes of data, and that data can be read back also very efficiently. Now, the question is, pandas is, Python is not for storing data or reading the real data which come out of the experiment. The whole Python framework will be mostly used for end user analysis. You understand the point? End
Yes,
user, if,
yes, yes.
for example, if you take an experiment, the experiment takes data and they put it in root format, which is very, very complex. Okay. And then there will be a lot of simplification of that complex data structure. And at some point, you will have a very flat root tree. Okay, so from a very complex root tree you will come to a flat root tree with relevant information which will be used for physics analysis. At that point Python with pyroot can be used, because pyroot actually is Python, but it is using root underneath. It has been already shown many times is that if you have some data which you do your analysis with in pyroot and normal C++ root, there is a factor of 20 to 30 performance loss in Python. That means the Python version with pyroot is 20 to 30 times slower than the corresponding C++ version. Okay, so this is already understood, but that is not the end of the story, because the pyroot doesn't use numpy. Pyroot actually doesn't use its own list. It simply communicates with the root framework, okay, and does the work. So it is slow because the communication is slow. It is data transfer is slow. It's not because of the data structure. Now there are, which you will learn from tomorrow, there is something called uproot. Okay, uproot actually doesn't use the pyroot, in the sense that it doesn't use the root at all. So what it does is the following: it will take the root file, it will read the root file and convert the content of the root file into numpy array. How it does that is, of course, very technical, but it will. So what is the norm today for physics analysis is that you store your data in root format, because that is the best format, no doubt about that. Starting from the basic experimental raw data all the way up to your analysis data, you store your data in root format. But when you do your analysis, then what you do is on the fly you convert your root data into numpy array, and you work with the numpy array. Because you are now working with the numpy array, your Python is much more performant than if you had done it with pyroot. That is why you know that nobody these days, except for demonstration purposes, and there is another thing which I'll mention, uses pyroot. Pyroot, although Arno will teach you pyroot, I think it will be it will serve much better if it also tells you more about uproot, because that has become an also other tools which are based on uproot have become the de facto tool for analysis. Why PyRoot is still important is because root has a this fantastic statistics package called what is called the roostat, roofit, roostat, etc., etc. That still uses the data format of C++. Okay, so you cannot write today itself, you cannot abandon PyRoot, because for statistical analysis you are not actually reading over all the data, you are actually reading over only few only few percent of the total data. So there PyRoot still is fine. So the day when somebody will tell me that all the roofit and the roostat facilities are available as Python packages in the same way, with the same kind of reliability, etc., etc., then I think that from that point onwards, people will only use the root data format as the input file. Then on the dynamically, they will convert them into, and there are tools to do that, convert them into NumPy array and do it in Python. People who like Python, I mean, not me. For example, I will continue to use root, okay, as long as it is there. Also, you have the from root tree, you know that in root 7, it's still experimental to some extent. From the root tree, they are going to RN tuple, which is much more performant. Okay, so it's not that root has given up. So root has the data frame also. Okay, I showed you one example. So like the pandas. So Pandas has become so popular that root also has the data frame, and the root data frame actually can revolutionize the whole analysis space. So if you have to learn, if you have to learn data analysis, you should, and you still have doubts about whether I will go to the Python way or the C++ way, and you know that some format close to root will continue to remain for as data storage. Okay, whether you will use that format for data analysis is up to you. So there are two options. One is that you continue to use C++ and root and RN tuple and root data frame either in Python or in C++, or you take the root as the input file, convert it into NumPy array, and there are awkward array and some other stuff just to help you out, and you do your analysis in Python. Personally, I don't like Python for data analysis. Okay, so I still prefer the root way. Is it does it answer your
Yeah,
question?
yes. Actually, lots of things are clear. Thank you. I just wanted to know your comment because I mean, people are using root. I mean, from a long time, and since the Python part is not developed up till such an extent that everything can be processed through the Python method.
Yeah, I think that's why Arun also put PyRoot in the agenda, that the statistics part is still based on PyRoot. But the statistics will work with the histogram. That means you also need the root histogram. So you need to learn PyRoot. So the only problem is that PyRoot is very slow. If somebody could speed it up in some way, okay, in principle it's not very difficult. You have to write more interface code. Okay, but also there are other problems, because in the world of multi-threading, in the world of GPU programming, etc., PyRoot doesn't really work. Okay, so that is why you have to move to something which actually fits in the new generation of tools. Okay, so for example, as I said, root data frame is GPU enabled. You don't have to do anything. If your machine has GPU, and if you say that yes, I want to use GPU, root data frame will use the GPUs. Okay, so that way it is a very advanced system compared to basic root based analysis. Any other
Mm,
questions?
Thank you, sir. I don't have any further questions.
If not, okay, I thank you once again for your participation and few of the, I mean, your patience also, because I gave a lot of introduction and so on. I hope with this introduction you will be able to follow the machine learning courses from next week. Okay, and also the I think tomorrow and uproot also will Statistics probably will not need Python, but uproot will need Python, and I hope you will be able to follow the NumPy part. So best of luck to you, and then I can close. I will stop the
Yeah,
recording.
thank you, Subir. Actually, it was very nice set of lectures. So I hope that the students will be it will be very useful for them.
Yeah, I will share all the notebooks, even if I have not.
Yeah, we have
I'm not
uploaded the
shown
last
you.
2 days, so the 2 days one will be uploaded hopefully by tomorrow.
Okay. Okay. Fine. Okay. Bye. Bye.
Bye. Thanks.